In order to be clear as possible, about why the integral over path 1 plus the integral over path 3 is equal to the integral of negative py over the area, I've had to include a slightly larger diagram and a little more explanation up here. I was trying to explain it by pointing to what I had on the board and for various reasons wasn't being very successful. Now, at least one of those reasons is I didn't really have on the board what I needed, and I was doing too much pointing. And it just wasn't convincing me that you were going to understand anything I said. So let's try to clarify it. Okay, and not discounting the reason that I wasn't as focused as I might like to be when I was trying to explain that. It was an impossible task, and it's no excuse, but let's try to clarify it. Okay, so here's my path from here around here. Here's path 1, here's path 3, consistent with the way the paths have been labeled. Now I've erased some of the calculations over here to give myself space to draw this picture. So we're going to explain this picture. But first, let's just be clear that if we have the same value of x here as here, then the value of x isn't changing, and there's no change in the value of our p function. The p function being the function that's multiplied by I. Okay, so the 1.03i here and the 1.081i here are values of the p function, average values of the p function over path 1 and over path 3. Those average values were obtained by averaging the values of the p function here. Now it's just 1 times I, so the p function has value 1, and here p function has value 1.061. If we average those on this path, we get 1.03. Now up here in this path, the p values are what? 1.05 at this point and 1.114 at this point. If I average those two values, I get something pretty close to 1.081. Now actually, if I look at what I have there, I probably should have said 1.082, but wouldn't make any difference. Okay? Wouldn't make a significant difference. The big deal is that this is about 0.05 bigger than this, and there's a reason for that we can understand easily in terms of differentials. So, why is the value for given x, why is the value up here different than the value down here? It's not because x is different, because x isn't different. It's because y is different. So we want to ask, what's the rate of change with respect to y as we move in this direction? Okay, because only y is changing in this direction. And that rate of change, well, the rate of change in this direction is just the derivative of p with respect to y. Okay, so this is the rate of change of p with respect to y that we multiply by the change in y, in this case a change of 0.05, to obtain the change in p between this point and this point. Okay, now that change is equal to py delta y. Py is very easily, here's our p function, x squared y, comes from right here. Py is x squared, that's very easy to verify. Delta y is 0.05, so that py delta y, rate of change with respect to y times delta y, excuse me, is x squared times delta y. Now, what's the value of x squared delta y? Well, when x is 1, that's just 1 squared times delta y, that's just delta y. If x is as big as it gets on either of these intervals, it's 1.03. So we could have a value of x squared equal to 1.03 squared or 1.06. So the change in the value of p due to the change in y is about 1.03 squared or 1.06 times delta y. Now if you kind of average those out, you see that the average is about 1.03 delta y. Now I alluded to that over here. I had the 1.03 times 0.05 equals 0.0515, and that explains this difference. But there are a lot of things about positive and negative and associated with the direction of the integral that probably weren't real clear in the preceding video. So let's come over here and see how that works. Okay, first of all, I've just drawn a bigger picture, and I've hopefully indicated clearly enough path 1 and path 3 within the closed integral around this path. Of course, we also have path 2 and path 4 to make up the whole closed interval, but we're only looking at the two paths that move in the I or negative I direction, because those two paths are the ones where the value of the integral is going to be affected by the p function. Again, why is that? Because we have to dot any integral along a path parallel to the x-axis by some multiple of I. Our dr, our delta r, is some multiple of I. In this case, path 1, the multiple is 0.03 times I. On path 3, we're going in the opposite direction. It's negative 0.03 times I. Okay? When we do the dot product, whatever the j component is has no effect. Only the I component has any effect, meaning that only the p function has any effect here. And as we've seen, this value exceeds this value by about 0.051, which is just what we would get if we multiply the average value of delta p by the 0.05 delta y. We get something pretty close to 0.051. Okay, so we're only interested in the p function. It's the only thing that comes out of the dot product when we're moving on path 1 or path 3. Now, anywhere on path 1 or path 3, for any value of x, the delta y for that value of x is between delta y and 1.06 delta y, as we've seen. The average, then, delta p, is pretty close to 1.03 times delta y. So the average value of the change in p from here to here is about 1.03 delta y, or about 0.0515. Repeating something I've said over there, but we want to see it here. Now, I've drawn a little tiny interval delta s here and a little tiny interval delta s here, subinterval of this short interval, our delta r vector, indicating that for the same value of x, the integral over this delta s will be added to the integral over this negative delta s. Okay, so this is probably redundant, but we have to understand that whatever the value of the function is here, it's going to be multiplied by the positive delta s. Whatever the value is here is going to be multiplied by the negative delta s. Okay. Now, the average value of p down here is 1.03. Average value up here is 1.081. Again, because of the py delta y. So when we do the integral of f dot dr over 1 and add it to the integral of f dot dr over path 3, this path and this path, the integral over this path is the 1.03 times the 0.03i dotted with the 0.03i. So it's 1.03i dotted with 0.03i. It's 1.03 times 0.03. Average value is 1.03, we're moving 0.03 units in the positive direction. So when we multiply the p by our displacement, this is what we have. Up here, our bigger number actually, the 1.081, that won't always be the bigger number, it depends on the function, but this 1.081 multiplied by the negative 0.03, because, of course, our displacement is in the negative x direction here, will be added to this. Now, if we factor out the 0.03, we get our 1.03 minus 1.081. The 1.03 minus 1.081 is, and I've left my negative sign off here, okay, the 0.03 is our delta x from here to here. Okay? And our 0.051 is just our py delta y. So that what we get when we multiply this out is negative py delta x delta y, or negative py times delta a. Well, that's an explanation of why we say that the integral over path 1 plus the integral over path 3 is negative py delta a. Now, I was, in the preceding video, did something a little bit ignorant, because again, I wasn't quite on top of what I was doing at the time. But these should have been pluses. They've been pluses all along. And anytime I put minus in there in the preceding video, that was a mistake. So we want to make that correction. Now we see that the contribution to the total integral due to this path and this path, to the two paths in the x direction, and the parallel to the I vector in the direction of or in the direction opposite the I vector, is just equal to negative py times the area over the region. Okay. Now, a similar argument for the q shows that the qx delta x delta y is what's equal to the integral of path 2 plus path 4. And the reason why this is positive and this is negative, well, we've seen why this one is negative. If you reason it out over the two vertical paths, you'll see why it's positive. We just do the same argument. We look at this and this. And I tried to explain that in class. I could try to explain it now. Maybe I'll follow up with just a brief attempt at explaining why this one is positive and this one's negative, because the question did come up in class. But I'm going to close this one off here. We at least accept that the integral contribution from these two paths has to be negative py times the py integrated with respect to area.